Hi all, today we are going to learn about the basic forces which are acting on an aircraft. So before directly getting into the forces which are acting on aircraft, let's start from one dimensional forces. Let's take a stone which is on the surface of earth. The only force which will act on the surface of this stone is weight. So this weight means weight is the mass times the gravity. As per Newton's law, force is equal to mass times the acceleration. So if a person is under a static condition, suppose let's say the person is standing on a weighing machine, so what will happen? It shows the weight. Let's say a person weighs 100 kg. So actually the kg refers to the term mass. So if we want to calculate the total force which is exerted by the human on the earth's surface, we have to multiply it by the g value of earth, which is 9.81, and so the weight of the person is 981 newtons in the downward direction. So this is the basic force, that is the body force, which will act on any static body or static object. If the same person moves to moon, the acceleration due to gravity on the moon surface is 6 times lesser than the earth. We can say acceleration due to gravity on the earth is 6 times greater than the moon surface, a or g. The notation can be either j or g. So the weight on the surface of moon for the same person, when we substitute the value, we will be weighing 6 times lesser. That is the reason when people walk on the moon surface, they feel like floating, because the gravity is 6 times lesser than the earth's surface. Now let's move on to dynamics. Let's take car as an example. So the car, when it is under the static condition, the weight will be acting on the downward direction, and the weight will be equal to mass times the gravity as per Newton's second law. So when the car starts moving in forward direction, the air flows over and below the surface of the car, which will create a frictional force, so that it creates an opposing force towards its motion, and that force we call it as drag. So this is the second force that we are interested in. Nowadays in the automobile industries and aeronautical industries, if we talk about the vehicle designs, they will say aerodynamically designed vehicle, or they call fluidic design. We have a fluidic car, Verna, in Hyundai. So there are a lot of inventions going on to reduce the drag, which will in turn, it will increase the efficiency of the car. So the second force what we are interested is the drag force, which will always oppose the motion in the forward direction. Okay, and when we talk about the third force, that is the forward force, this force is responsible for the movement of the vehicle in forward direction, but we need some power producing element to get this force. When we are talking about the drag, let's take this car as an example. This car has got a fluidic design. When it is moving under a high speed, this can produce a much larger drag, because it has got an open area here. When it is closed, it can cross more than 100 kilometers in a few seconds. But let's take the bus as an example. This has got a rectangular in shape. This has not any fluidic design or any aerofoil shape. So the flow will be having a lot of restrictions. So comparing to these two vehicles, the drag will be much higher in this kind of vehicles. But the seating capacity and many more applications are different. So let's not talk about that. Let's only stick to about the drag portion. Now the third force that we are interested in, the forward force. This forward force is called as thrust. The denotation is T. So this thrust is produced in the forward direction of the vehicle, and the thrust producing component is known as the engines. Engines are the main, or we can say, power plant. So power plant is responsible for the production of thrust. Now we have come across there are three components, that is the weight in the downward direction, drag in the opposite direction of motion of the vehicle, and thrust in the forward direction. The only force which is missing in order to balance the force component for an flying vehicle is in the upward direction. That we are going to talk about in the next slide. As we know, weight will be in the downward direction, drag will be in the reverse direction, that is the motion which is opposing the flow. So these two components are actually a naturally occurring elements. So these two components are naturally occurring when it is under the motion or under the static condition. And engines are the power plants which are responsible for the thrust production. So in order to make any vehicles fly, or we call it as a flying vehicle, we need one more force that needs to be balanced, that is in the upward direction, because thrust and drag we have in the opposite directions, and when we see the weight, it is in the downward direction, and the only force which is missing is in the upward direction, which is the lift, and this lift is generated by the wings of the aircraft. Both the wings will generate enormous amount of lift, and that is responsible for the taking off, and the endurance portion of the aircraft is mainly due to the lift generation part. So these are the basic forces which are acting on an aircraft or any flying vehicle. Now let's see some bonus information with respect to the aircraft. We are going to compare all the three Newton's law with respect to the aircraft. Let's take the third law first, which is the most simplest and easiest law. For every action, there is an equal and opposite reaction. The thrust produced by the engine will be in the right direction. Since the engine is fitted to the aircraft's thrust production will be in the left direction. So equal and opposite reaction. Action will be in the right direction, reaction will be in the left direction. And now let's move on to the second law. Second law states that the rate of change of momentum is proportional to the force. So the momentum states that mass into velocity. So there are two kinds of engine actually. One is a propeller kind of engine, which is an older day engine, and now we have turbo engines. And the thrust production in terms of forces is having a small difference. Here in the propeller engines, if we see the equation, the rate of change of mass flow, that is the dm, is very much greater than the velocity change in case of propeller engine. But in case of turbo engines, the rate of change of mass flow is comparatively low when compared to the velocity change. That is how the thrust is produced in the turbo engines and propeller engines. Now let's talk about the first law. First law states that when a body is in a state of rest, until and unless an external force acts on it, it will not move. Similarly, when a body is in the motion, unless an external force acts on it to stop it, it won't stop. Let's say a stone lying on a surface, it will not move until an external force acts on it. Let's say an object which is moving outside of the earth, which will move in the straight line unless an external force acts on it to stop, it won't stop. So when an aircraft is flying, let's say an aircraft is flying in any direction, when we manage to maintain all the forces, that is the lift is equal to weight, thrust is equal to drag, then we can apply the Newton's first law as well. This is how we connect all the three laws with respect to the aircraft and its applications. Thank you.